Today I will show you how to make a data logger using the Arduino Nano, a microSD card, and a microSD card adapter. As you can see, this is only a 3.3 volt linear voltage regulator and a level shifter IC because the microSD card runs on 3.3 volts but the Arduino runs on 5 volts, so it's not compatible. If you're making your own boards, you can supply the Arduino from 3.3 volts and directly connect the microSD card to it. It uses the SPI bus, so just connect the SPI connections from the Arduino to the SD card on your own board. I will also be using my electronic load. As I said, I want to set up an automated testing device to test battery capacities and compare how much they last. And in order to do that, I'm also using a speaker to tell me when the test has finished, if everything has been okay. For example, the SD card has been detected, the data file has been created successfully, and if there's any errors. And I have a small demo set up right now which plays the three different sounds. The first one is for when everything is okay. Let's start. The next one is for when there's an error. And finally when the test has finished and I need to replace the battery. I've used fairly basic sounds which are inspired by car locks and microwave oven sounds. You can create your own if you prefer, but I'm just gonna stick with it because it's gonna get the job done for me. Now let's go over the code for the data logging aspect of the Arduino. Here's my sketch. As you can see, it's called battery tester. I've included the wire library and the Adafruit INA219. That's the chip that I'm using to do the current sensing, and it's communicated via I2C, which is what the wire library is for. I'm also including the SD library and the SPI library. They're used to communicate with the SD card basically. And here I'm initializing the INA219. I'm setting the speaker output pin to pin 9. I'm also setting the chip select pin for the SPI connection. I'm also defining a sampling delay and a cutoff voltage for the batteries. You can just use whatever value that you like, and you won't need the voltage cutoff if you're measuring, for example, temperature data. In the setup, I'm just setting up the speaker output as output, the chip select as output as well. I'm initializing the serial line and I'm setting the timeout on it to be 10 milliseconds. That just reduces the delay from when you enter a command and when it's executed by the Arduino. I'm initializing the INA219 and setting its mode to be 16 volt 400 milliamp. That's more accurate in the lower current ranges. We'll be using 100 milliamps maximum, so that's not an issue. Then I'm testing to see if the SD card has initialized correctly. If it has, play the OK tone. Otherwise, play the fail tone and wait there. Don't proceed any further because you can log any data if your card hasn't been initialized correctly. These are just the three tones that I showed you earlier. You can create whatever tone that you like. It's not really important here. And let me skip to the loop. I'm just checking if the serial line is available, otherwise waiting for when it's available, reading the data from it as a string, removing the last character, which is a new line character. We don't need the new line character. And I'm saying if the data is equals to the string test, start the test, call the function start test, and that's as simple as that. You can write your own test function here, but I'll go over mine and explain it quickly as well. So here's my test function. First thing, I'm asking for a file name, saying save as, and waiting for an input from the user, reading the file name from the serial line, removing the new line character from the end of it, adding a suffix of .csv, which stands for comma separated values. You can import that directly to Excel, so you don't need to do any further work. You can just open it in your Excel and draw the charts that you want or whatever. And I'm just printing the file name to confirm the final file name. Here I'm checking if the file already exists on the SD card because I want to avoid overwriting files. If it does, play the fail tone and print the file already exists and exit the function. Otherwise, create a new file called data file and open it on the SD card for write and check if the data file has been created successfully. If it was, make a OK tone, and these are the variables that I'm using to do my energy logging, power logging. You don't need to worry about that. You can use your own variables. I'm also using a timer called tstart equals to the millis functions and the time elapsed, which I'll be using as well. Here I am just getting the load voltage, which is equal to the shunt voltage in millivolts divided by 1000 to get volts, plus the bus voltage. There's gonna be a very small voltage drop across the shunt resistor. In our case, it's gonna be less than 1 millivolt, but I've just added it to make sure there are no weird errors. You can ignore it and use the bus voltage in our case. We're not using high currents. The shunt voltage is not going to be that great. It's called the burden voltage. Feel free to read about it online. I'm not going to explain it here. Then I'm using a while loop to say while the load voltage is more than the cutoff voltage. Again, calculate the load voltage. Get the current from the INA 219. Calculate the power. Here I'm testing to see if the current is more than 1 milliamp, maybe the battery has died or I've disconnected the load. And if the current right now is more than 80% of the average current, again, if I turn off the load manually, pausing the test basically, I don't want the value to be recorded because it's not an accurate value and it can throw off measurements. I'm just basically stopping logging data if these conditions aren't met. Otherwise, write in a new line the current, the voltage, and the power using comma separated values. But that basically means whenever there's a comma, that's the next value. And that's just for the Excel to understand where each new value is, and I'm doing some more energy calculations both in milliamp hours and watt hours. Then I'm waiting for my sampling delay. You can set it to the value that you want. At the end, I'm logging the elapsed time, printing the milliamp hour capacity, printing the milliwatt hour capacity, and saying the test has finished successfully, playing the tone so I know the test has finished. I don't want to be looking at the serial monitor the entire time, closing the data files, and if the file hasn't been created successfully, just play the fail tone again and print an error message to the serial line and exit the function. Okay, I have the file uploaded to the Arduino, and let's see it failed because I don't have the microSD card plugged in right now. It's trying to initialize, but it failed as you saw. So let's put the SD card back in the Arduino. Here it is. This time it should successfully initialize. There it goes. And for this test, I'll just use a 12-volt supply line because I don't want to actually start testing the batteries right now. So let's plug it into the load, turn on the load, and here on the computer I'm just gonna write start test, or sorry, just test, and it's asking for the file name. I'm just gonna call it, I don't know, 12-volt test. Started the test. It's logging the data and waiting for the voltage of the supply to go below the cutoff voltage that I've set earlier. That's not gonna happen in my case because, as I said earlier, I'll be using a 12-volt wall adapter. I can just disconnect it to simulate the load being disconnected. I can also pause the test. As I said, I've set the condition, so if I disconnect the load, the test is not going to finish. It's just going to be paused, and the data won't be logged until I increase the current to more than 1 milliamp again and starts to log the data again. I'll show you how it looks in the CSV file later. And if I disconnect it, you should hear the test finish sound. There it goes, and as you can see, it tells me test has finished successfully. Let me also show you if it tries to overwrite the previous data files. Start a new test, saying 12-volt test. You can hear the error sound, and it says the file already exists. So everything's working fine. Now let me show you the data on the SD card in the Windows. Here's a picture of the micro SD card plugged in. As you can see, the 12-volt test file exists. Now let's jump back to the Excel and let me show you how the data looks on there. Here's the file just opened in Excel. As I showed you earlier, I'm logging current, voltage, and power in milliwatts. And if I scroll down, at no point can you see 0 milliamps because I paused the test, but I never really logged the data when the test was paused. As you can see, the current fluctuates a bit from 100.1 to 100.2 milliamps. That just comes down to the error, but my load is keeping a fairly constant current, so I'm not really worried about that. And as I showed you earlier, I'm taking an average current as well, so these small errors should not really affect the test in any meaningful way. And I'm gonna scroll down to the bottom because that's where I was logging the final values for the capacity in milliamp hours. Oh, look at that, that's just 1 milliamp hour, and the capacity in milliwatt hours is also logged. I can also confirm the results using an online calculator. The voltage was about 12.3, 12.4, and the capacity is 1 milliamp hour, so let's see what that turns out to be. So as you can see, I've put in 1 milliamp hours at 12.4 volts. It's giving me 12.4 milliwatt hours, or 0.0124 watt hours. But my data logger said it was 15 milliwatt hours. I actually believe that value more because, as I showed you, the voltage is varying and the current is also not perfectly 100 milliamps constant. So yeah, the results are fairly close, but I trust my own values more than the online calculator. I think it's a good place to leave this video, and in the next one I'll show you the testing of the batteries, their capacity, and how the automated system works in action. Hope you enjoyed this video. See you guys in the next one.